Okay. Hey, what's up? Okay. All right. So, what we're gonna do is we're gonna start with each page, okay? And I'm gonna bring in each of these pages, and we're gonna just go one at a time. Okay. All right. Let's start with number 1. So the issue is find the values to all the variables. You are not, and I underline not allowed to use a Pythagorean theorem. What? Did you not read that, Daniel?
I did.
Did you use a Pythagorean theorem?
No, I didn't.
Okay. All right. So I'm going to bring up my calculator, and hopefully my calculator. Gosh, I hate when a calculator does that. Doesn't want to shut this down. So let's figure this out. How do we figure out these things? Let's go through this one by one. No, you don't. Yes, no. Anybody?
First, I'd figure out the other angle, which is 60.
Okay, you want to figure out the other. What do you want to do?
Just to have it, figure out theta.
Okay, so let's figure out theta. So what's theta in this one here? Actually, I think I might use a different. Let me use a different color. You think I should use a different color? Just for clarity's sake, I'm going to use aqua blue, which may come up as pew blue on the screen over here. All right, so this is how much? 60 degrees. Can you see that? Barely. Okay. How'd you get 60? Right, and because we're right triangles, every triangle is going to have a 90 degree in it. That means that the two other angles add up to 90 degrees. So you can just go from that standpoint. Where's my brush puck? A little bit deeper. Okay, so that's 60 degrees. Great. Okay, so we've got that. So the question was, how do you figure out? Oh, I didn't even ask for this leg over here. That was easy. How do we figure out h? How do we figure out h using the non-Pythagorean theorem? Well, okay. Well, that was like, that's too simple. I mean, what if I use cosine with the 60 or the 30? All right. So that's so what do we say? We say give me an equation. Cosine of theta equals what? Don't give me the rolling of the eyes. I want you to do this. Cosine theta equals what? Okay, so ka, right? So it's adjacent over hypotenuse, right? That's where I want you to, guys, I want you to start here. In your tests, I want you to start here. This is what you've got to do right there first. Okay, that way I know what you're doing, right? Does that make sense? Do you understand why I'm asking you to do this? You okay? You look? All right. I'm asking you to do this because I want to make sure that, let's say here's an example, right? If you don't do this, and let's say you forget, and you say opposite over hypotenuse, right? Then I can say, well, they got that wrong, but the rest of it I can go through and say, okay, better credit for it, right? If you don't do this and you go right to the numbers and you don't put what you think is incorrect, then I can't give you partial credit. Does that make sense? Now, are you wrong if it's opposite over hypotenuse? Yes, and I will take off for that. But the rest of it I can give you partial credit for. Does that make sense? So do this. It's not just for me. It's for you. Okay. So cosine theta. So cosine of what? Which theta are we using? I'm sorry? 30. And that's because for 30, you have the adjacent. This is our adjacent. So it's our 5 over our h, right? So now what do we say? Right, h equals 5 over the cosine of 30 degrees. And I'm going to do it quickly here just so you guys can see it calculator-wise. So because I've got this simple basic calculator, I know it's cosine of 30 under 5, right? Divided into 5. So what I'm going to do it a little bit roundabout. So I'm going to say I'm going to make sure I'm in degrees. Number 1, I got to make sure I'm in degrees. What are you in, radians or degrees? Harrison?
Radians.
No! You should be in degrees. Wake up. Okay, so 30, I'm going to say, I can see because you're looking down somewhere else and you're not looking up here. 30 cosine. Okay? That's 0.866. Yeah. So because it's the denominator, and I get this basic calculator, I do the 1 over, which means I invert it. Does that make sense? Everyone understand why I'm doing that? No? Yes? You can say no.
Can you also multiply times?
Hmm?
Can you also do it times 50?
No, because then you get but then you'd have to invert it again. Right? So 1 over and then times 5. So you should get 5.77 something. Did everyone get that? So h equals 5.77 something. Everyone with me? Okay. All right, good. Now, I didn't ask you for this guy over here, so I'm going to leave that alone. Okay? Let's go and let's look at x and h. Let's do this now. How do I get, if I've got this guy down here, I get 25 degrees, how do I get x? Ah, I can use tangent. Why am I using tangent?
Because tangent is opposite of adjacent.
Okay, because since I didn't ask you for the angle, right, I'm just going to ask you for the x. And so the tangent, right, the tangent of what? Of theta equals what?
Tangent of theta equals,
Come on, guys, wake up, wake up. Everyone should be able to say this right away. Quickly, everyone together, what does tangent theta equal? Beautiful. It's like a nice, pretty choir. I like that. I know it's like Monday morning. You're like, okay, Mr. A. All right, so the tangent of 25 degrees equals my opposite, which is what? What's my opposite? 3. And how do I know it's opposite? Again, I go from, if I want to know it's opposite, I go from the corner all the way through, go across, there's 3. So 3 meters over my what? Adjacent, which is what value, Paulina? What is my adjacent value? Look, I don't have to do this. You guys are, look, I don't have to go over this. Is this boring for you guys for me to go over this? Okay, all right, let's go over this. So, over what, guys? Over, Paulina, what's the value for adjacent? No, what's the value? No, in my equation, but in my equation, I'm here. Look at where I'm at. Tan of 25 degrees equals 3 meters over what? My adjacent is what value on this triangle? Someone help Paulina out. What is the x?
Oh, I was giving you a number.
I know. Pay attention, please. This will go faster if we all pay attention, okay? So that means x equals 3 meters over the tangent of 25 degrees. So what does now x equal? I'm not going to do the calculation. Someone else give it for me. 6.43 what?
meters.
Notice the difference between number 1 and number 2. I have a what? I have a unit. So you got to put the unit down. Got to put the unit down if there's a unit. Now look, the unit can be anything. It doesn't matter. Meters, inches, miles, newtons, right? It could be B field, Tesla. It could be anything. Okay? It could be pink elephant units, right? It's only 6.43 pink elephants. That last elephant kind of got the 0.43 of an elephant. Yes, I'm sorry.
Can I see the? Sorry.
Can you not see it?
No, I see the very bottom part.
Okay. X equals 3 meters over tangent 25. X equals 6.43 meters. Okay. All right. I'm sorry they got printed I made it landscape. They got printed portrait for some reason. Okay, number 3. Let's look at number 3. How do I deal with number 3? What am I looking for? Now, notice I tried to trick you. And how did I try to do that? I rotated the triangle, right? So now, I know, I'm sorry. Okay, so what do I do here?
Finding the A.
I'm sorry?
Finding A, which is Y.
Find the what?
Adjacent, which is Y.
Which is y. Well, how do I find adjacent?
Do the side, the side.
Wait a minute. Can I find my y value first?
No.
No. If I'm not using the Pythagorean theorem, which you shouldn't have done because it says no Pythagorean theorem, You can't find the value of y yet, can you? No. What do you have to do? Okay, so I have a hypotenuse, an angle, and a value that is what? Opposite or adjacent of that angle? Opposite. So what uses opposite and hypotenuse? Sine. You see where I'm going with this? This is how you got to think about this. What am I looking for? Can I find y? No, not necessarily. I mean, I could if I used the Pythagorean theorem, but I'm not letting you do it. I'm tying your hands behind your back. So in order to find, and you're saying, why, Mr. A? Because I know this sounds silly. No. I've heard this conversation before. Well, why can't I use a Pythagorean theorem? The next thing that we do with this, it's going to be more beneficial and time efficient to do it this way and not use the Pythagorean theorem. Because if I got to get to the theta by using the Pythagorean theorem, I got to do Pythagorean theorem and then theta. It's 2 steps. Whereas in this case, I can do it in what? 1 step. You follow me? So this is my pure example of why you should do it this way, okay? So I know that sine of theta equals my opposite over my hypotenuse, right? And now the thing is I have sine of theta, which is now my variable, is my opposite. What's my opposite? What value is my opposite? 4. What's my hypotenuse? 10. Okay. So now how do I find theta? How do I find the value of theta? It's very important to be able to do this.
Inverse sine.
Okay. I have the inverse sine of 4 over 10.
Why do you do it in this way?
Okay. Because the way that without getting into the actual definition, in this case here we have an angle, right? We have cosine 30 equals 5 over h. Well, cosine 30 is a number, right? We're functioning that number, so we can say we know that that's a number, so we can do some basic math. The problem is because this is a function of a number, you have to take the inverse function to get there. So the inverse sine of the ratio equals theta. So if you're looking for theta, it's the inverse of the ratio. You can't just swap these two in and out. The sine of 4/10 does not equal theta. The inverse sine of 4/10 does. Okay? So now let's do that on our calculator just so we can see that. So 4 divided by 10, okay, so 0.4. And we're going to do the sine. Well, I don't see inverse sine here, so I have to do the shift button on my calculator, and I can see the -1. Do you guys see that? So the inverse sine of that is 23.57. Now look, I've got to be in what do I need to be in, Harrison?
Degrees.
Beautiful. There you are. So that means theta equals 23.58. So theta equals 23.58 degrees. Are you with me? Cool beans? Does that make sense? Okay, anyone who didn't get that, do you get it now? Yes, ma'am.
Sorry, do you want us to round to the 100?
Yeah, I'm less concerned about that. As if you're 1 or 2 places, that's okay. And I'm going to be look, I'm not a sig fig guy. I apologize, and I know that's heresy in some places, but this is, practically, if you know how to do sig figs, right? Do that. I care more about getting your process. So you're saying it's 1 or 2 places, doesn't matter to me.
When we cut it off, did you round it or no?
I rounded it up. Yeah. So round that up. So it's like, 0.58. Something that you can round, and maybe I'll say to the 2 decimal places accuracy. All right. If I don't say it, guys, 1 or 2 decimal places is enough for anything we're really going to be doing. Unless we're really in a scenario. Now look, if I'm doing everything at 0.1 if I'm using every number at the hundreds or the thousands place, you're going to have to do that, right? If I'm dealing with thousands, I'm going to make sure that I'm dealing you're dealing in the right precision at that point, right? So if I'm dealing if let's say I was trying to triangulate, this is 30 thousandths of an inch, 0.03, and this is 0.02. Well, in order to find the hypotenuse, I should probably keep myself at least to the 2 hundredths place, for the hundredths place location or of precision, right? So think about what's practical, what makes most sense, right? You don't want to round to the whole number at that point. Okay, so that's theta. Now, how do I get to y? Okay, so now normally you would use a Pythagorean theorem because it's probably the most precise way of going because I've got a rounded number. But because I told you can't, you have to use the rounded number. So you're saying, well, you could use who said cosine? Who said cosine? Cosine. Why'd you say cosine? Well, okay, but cosine uses what things? The and hypotenuse. Is that the only thing you can use? What else could you use? Tangent. Be sure that you understand what two options you could use. I could tell you do it both ways on a quiz or test. By the way, test will be next Friday, a week from Friday. I'm going to give you guys a test so we get that squared away.
Is that the one that has the section you can replace the...
Yes, that will have the quiz replacement section. Yeah, let's get that thing out of the way. All right. Yeah. Sorry, kiddo. All right, well, don't listen. Don't mess up your opportunity. Don't mess up your opportunity. You've got another. This doesn't come around all that often, by the way. This will not happen again. So use this opportunity wisely. All right. So I said, okay, let's use cosine. So the cosine of theta equals what? Cosine of theta equals everyone. I'm sorry, adjacent over h. Guys, I'm going to say this again and see it's on record because it's being recorded. So if anyone says you didn't say it, it's right here. You must do this equation first to get full credit. Give me the equation with variables in it. This is my recorded statement. Okay, statement of proof that I did actually say this. All right, so you must have this, right? There's no argument now. And then I say, okay, well, the cosine of theta, which is what? Bueller? Cosine of? What? No, but what's the theta? What's theta? 23.58 degrees equals my adjacent, which is what? Y over my hypotenuse, which is 10. Okay. Are you ready? Now, how do we find y? Well, y equals what? Right, 10 times cosine of 23.58 degrees. Right, so y equals what, guys? How much? 9.7, 1 or 2, okay. All right, good.
Wait, so
9.17? Oh, I'm sorry. Hold on one second. What was your question? I'm sorry. Y equals 10 times cosine, right? Because I'm just bring the 10 on both sides. Yeah, it's 10. Is that 10?
Yeah, I think so.
Okay, we're there. We're good? Everyone with me? We're all good? Good times? Okay. Good times. All right, so let's figure out, how do I figure out on number 4, how do I figure out theta? Well, which function are we going to use? Which function, what things do I have? I have if I'm looking at theta, what sides do I have relative to theta? What sides? Opposite adjacent. So which trigonometric function involves the angle, the opposite, and the adjacent? Tangent. This is a step by step you got to take. So the tangent of theta equals what? What does tangent of theta equal? Equation? Beautiful. Opposite. See there? Those people answering will get full credit. Opposite over adjacent. Okay. Beautiful. Okay. Okay, so now I plug in my numbers. Do I have theta? No. So I have tangent of theta equals, what's my opposite value? 5.5 what? Okay, over what?
7.2 meters.
Beautiful. So that means the inverse tangent of 5.5, now my meters will cancel, over 7.2 equals theta. So theta equals, let's do this again. So 5.5 divided, 5.5 divided by 7.2, and then the inverse tangent. Oh, that gives us 37.38 degrees, right? 37.38 degrees.
On like a Quizzer test, if we don't put like the tangent theta over equals opposite over adjacent, like we do that part first. If we go straight to tangent -1 and 5.5 over,
Wait, if you didn't do these two steps, you mean?
yeah, those two steps.
Gotta happen.
Even
Got
like the second one.
Again, we talk about, okay, I'm going to talk about, again, really briefly, my process for credit, okay? Step one, I did this in the last test. Step one is equation with variables.
No, but like for that one, like specifically, if we put tangent -1 opposite over adjacent equals theta, like immediately, that's the first thing we put. Is that not
Oh, I see what you're saying. I'm sorry, I got you. I see your point. I'm sorry, I got you. If you went like right to here and you said tangent -1 of theta, of opposite, you can do that. That's fine. That's fine. Yes, I get your point. You're saying do this, but the inverse tangent. Yes, you can totally, that's fine. And the reason why I'm okay with that, here's the reason why I'm okay with that. The reason why I'm okay with that is I know you've got an equation with variables, right? And I get that, and that's fine by me. Okay? Okay. Right, I know what you're trying to do, and I can give you partial credit. If you went right to this point right here, oops. If you went right to this point here, then you wouldn't get full credit. Does that make sense? Okay. All right, so now I've got my theta. How do I figure out my h? How do I figure out my h? Not using Pythagorean theorem. You could, okay. Okay, could you use, is sine the only thing you could use? What else could you use? Cosine, right? Because again, you've got the hypotenuse, you're looking for the hypotenuse and you've got opposite and adjacent, okay? So we're going to say, so the sine, you guys want to use sines, the sine of theta equals my opposite over hypotenuse, right? So sine of 37.38 degrees equals my opposite, which is what? 5.5 meters over hypotenuse, right? So h equals 5.5 meters over the sine of 37.38 degrees, which means hypotenuse is what, guys? Does everyone have an answer for this?
Yes.
Okay, what does h equal, guys? 9.06 what? Guys, do not forget your units. Do not forget your units. Cool beans? Cool beans. Okay. All right, I'm going to add another image. Edit the image. Find the image. Go to my local browser. Page 3. And then I'm going to squeeze that down. All right. Huh? Okay, so I'm going to do this so I can kind of like give us some space to work here. Okay, now notice, what have I started to do here? What have I started to do?
Determine differentiate between vectors and displacement.
Yes, but exactly opposite. I'm not differentiating. I'm showing you that it's the same thing, right? I'm showing you that all of a sudden I've got a vector, but my distance or my displacement is a vector, and velocity is a vector, right? And I'm showing you that I can start to apply some units. I'm trying to scaffold this so you can see that, hey, these vectors are going to be useful for us. Hee, ha-ha, ho-ho. Okay, all right. And you'll notice I did a couple of things here. You'll notice that what I've done is I've labeled some things very clearly. And I did this intentionally. I want you to look at this. So I've got a vector. Let's look at number 5, okay? I've got a vector, and we're going to call it D for displacement, okay? Everyone with me? All right, I should have a little arrow above it, but I didn't do that. Oh, sweet. I got a little vector D, right? 25 meters, okay? I have D sub X and D sub Y. And I actually have I didn't show it here, but there's actually a D sub Y. Okay? Now, what does that mean? Talk to me. Someone talk to me about what you think that means.
Distance in the x
Correct. Okay? So here's the thing. And when we talk about this, when we're looking at, and I talked about it briefly, okay, last week, but I want to talk about it again. When I have this, and by the way, what direction does the dy vector go? If I were to draw a vector for dy, what direction would it go? Up or down? Up. Does everyone see why it's up? No? Do you see why? Because if it was down, then it would be going down, right? And because now here's the thing: when you let's say I gave you a vector like this and a vector like this.
Wait, what do you mean it would be going down exactly?
Okay, let me explain. All right, here we go. Here, and this is something I haven't talked about, but I'm trying to get there. Watch this. I'm going to add the two vectors together. Okay, I'm going to show you this version versus this version. Okay, when I add the vectors together, I put them end of one vector next to the beginning of the other vector. So I'm doing this, and I'm doing and I'm doing this. Notice that the tail of one vector begins at the end of the other vector. You follow me? Here, if I did it, it means something completely different. Now it's down like this. Notice there are two different things. The resultant vector is here. The resultant vector is here. Do you see the difference that this makes? A down vector, if I drew the arrow down over here, it really would mean that the resultant vector isn't this. The resultant vector is this. You guys see that? Which you're like, well, it's just an arrow. The problem is it's a different angle. This is an angle positive, and this is an angle negative. You see the difference? So what we're doing is we're actually adding vectors. And what does that mean? Let's think about this for 1 second. I just want to make sure I sort of drive this home, okay? When I add vectors, right? Let's say I want to get from the bless you. Let's say, I'm going to erase this for a second. I'm going to try and do this so we can see this. Let's say I had a room, okay? Let's say we had our room right here, okay? Here's our room. Here's a door right there, right? Everyone know the architectural sign for a door? Okay. All right. Let's say you're starting here. Here's where you start, okay? And I want you to get to here. Well, your response is, Mr. A, the shortest distance between 2 points is a straight line, right? But I could have also done this. I could have said, you know what? I'm going to go this direction that much. And, when I say and, what do I mean mathematically? Plus this direction that much. Correct? Together, once I add those two vectors, the net result, everyone understands what I mean by the net result. The net, what I'm left over with, what I'm left over with at the end, is this. Everyone see that? So what I'm really doing is I'm adding a distance in the x direction plus a distance in the y direction to give me a final distance vector. Does that make sense? So I'm really breaking this down. So I could go both directions. One, I could say, hey, I've got these two things, right, and I can add them together. Or I could divide this one vector into two things. Okay? And you're saying, well, Mr. A, why would I care to divide this? Why? You already have the end result. Why do I want to go any further? Why do I want to go a longer overall distance, but to get to the same displacement vector, right? You're like, the straight line's the quickest way. Well, here's the thing, right? Let's say you normally want to go a straight line, but let's say that there's actually a table in the way, okay? And you can't get through that table. So the only way to do it is to then go this direction and then this direction, those two vectors. Does that make sense? Now this is, extremely rudimentary. I get it. You know, you probably hop over the table. I get that, right? Or move the table. Because y'all are smart that way, right? But the reality is, okay, I may need to understand the x component and the y component of these vectors. So these dx and dy, or vx and vy, these are the x and y components of that vector. This is really important. A lot of what we do from now on in mechanics is going to be based on this concept. So please, does anyone have any questions about that right now? Any questions at all? Okay. Because when I have, let's say I take an object, Lauren, and I toss it to Lauren. Ready? It's gonna have a velocity going out there, right? It's gonna have a motion. Throw it back. It's gonna have a motion, right? Well, that's one arced motion, right? That motion would be throwing something, right? If I throw something to Lauren, here I am, okay. Here Lauren is, and I throw something to Lauren. It's gonna do one of these things. Oops. Yeah. It's gonna do one of these things, right? It's gonna have an arc to it, right? But that arc, that velocity, and that at any point in time, I can have a y and x thing. I can actually describe that in x and y. I can describe that from a positional standpoint, x position, and a y position. So when I'm here, I have a certain x and a certain y. Here I have a certain x and a certain y, right? And so forth. In addition, my velocity is going to have a certain velocity component, x and y. And the beauty thing about this, and we'll get into this soon, is that the x component of the velocity and the y component of the velocity, Lauren, heads up. Oh, almost, right. Back over. The x and y are completely independent. Okay, so, okay. Shh. All right, so it's very important. The x and the y, guys, the x and the y are completely independent. Completely independent. It's very important, Harrison. Very important. Okay. All right, so again, I want to be very clear about this adding of vectors. I kind of went through that quickly, but does everyone understand my adding of vectors concept? Okay, because if I added it, if that last vector was negative, if that other vector was negative, okay, then I'm going to get a different resultant vector, right?
It's the opposite, right?
Yeah, it is exactly the opposite, right? Because this vector, again, if I have a vector here and I add a vector here, it's going to be a different resultant vector than this and this, isn't it? Does that make sense? Same thing as if it was this and this, right? Does everyone see that? Anika, you see this? Okay. Even if any of those vectors are opposite, you're going to get different results when you add them up. Okay. All right. Okay. All right. So let's do this. Let's do this now. Okay. I'm gonna take this and erase this. Because I didn't want dy necessarily. What's our timing like? What time do we end? 10.
7 minutes.
Beautiful. Plenty of time. Okay. So we're looking for dx, right? Which is, let's all say this together, the x component of the displacement vector. Ready? Dx is the? Okay, let's try it again. More like a unified song here. Ready? Say again. The dx is the? Of the displacement vector. Okay, the x component of the displacement vector. Okay? So, now, is the math any different than what we did before? Is the math any different? No. The math is no different, but we're now using vectors. So I want to be very clear that we can do this, right, without having to worry about the idea that we're using vectors instead. We're using displacement versus just basic. Oops, that's not what I wanted to do. Oh, okay. Here we go. Sorry. Here we go. All right. So I want to make sure that we understand that we're using that even though we're using vectors and distance, displacement, and we're using velocity, the math is the same, right? Okay, so how do I figure out the dx component? How do I figure out dx? How do I figure out, in number 5, how do I figure out dx? I'm sorry? You're not sure how to figure out dx? Okay, what do you have? You have an angle. Okay, of that angle, you have what length of the triangle do you have? The hypotenuse. And what is dx relative to that angle? It's the what? Adjacent, right? So it's it's nothing different than hypotenuse and adjacent. By the way, this is why I'm doing this, because I want you. The triangle's exact as before, but now it's like all of a sudden I put meters and dx. And you're like, right? I don't want you to. But this is. But I'd rather you freak out now than on the test, right? So it's no different. So I say, okay. I say the sine, or what did we say? I'm sorry. What were we using? Cosine, right? Because it's cosine versus adjacent and a hypotenuse, right? So the cosine of theta is equal to my, what is it? Adjacent over hypotenuse, right? Adjacent over hypotenuse. So the cosine of what's my angle? Everyone? 25 degrees. And what's my adjacent value? On this, what's my adjacent value? D sub x, right? You see that?
Yeah.
This is why I'm asking you to do this, D sub x.
Sorry, I had it labeled.
That's okay. Yeah, but listen, when you put this, this is important. Everyone look over here, please. Everyone look up here. Everyone look up here.
Hey, Mr. A, what's going on?
What is that? All right. So when we go from this step, are you really? No. Okay. Just checking. So as I go from this step to this step, look up here, guys. Do not continue with A and H. Put your values in. This is the value. We're adding, this is our equation with variables. And now we're going to put our values in. We're substituting our values for our variables. So the value for adjacent is what? D sub x. So make sure you, because otherwise I don't know what you're doing. If you continue with A and H, I have no idea if you know what A and H is. You follow me? Is that clear? So what's my H value? 25 what? Beautiful, meters. So now, how do I find D sub x? Harrison, how do I find D sub x?
You use cosine over.
I'm already here, kiddo. Look up here. Where am I? Now where do I go?
Then you.
What does D sub x equal?
Multiply cosine of 25 times 25.
Okay, so D sub x equals 25 what?
Meters.
Meters. Got to put the units in there. Times cosine of 25 degrees. Now, again, the reason I'm putting the meters in because what is this essentially becoming for me? What is this? What is essentially this cosine 25 doing? It's a what? What is it acting as? What did I use this before? I used this term last week. It's a percentage, right? This cosine 25 is just a percentage of my 25 meters, okay? If I say 25 degrees and I say cosine, it's how much percentage of that? How much of the 25 meters? It's how many percentage? 90, almost 91% if I round it. It's about 91% of 25 meters. It's not the full 25 meters, it's 91%. Does that make sense? So that's why I want you to put the meters in here because the only thing that carries units is the meters. So times 25 equals, so D sub x equals 22.65. So D sub x equals 22 point, what did I just say? 66, right? 66. Oops, 6 what? Meters. Okay? Now look, I want you to notice something. Now we're going to break in a minute here. In a configuration just like this, I'm not even going to tell you. We'll deal with it. I don't want to deal with it until we do more of these. All right? All right, we'll finish this up tomorrow. Yeah,